Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very interesting problem with complex numbers. I know a lot of people are going to complain about it, and we'll talk about it, and I'm going to ask for your input. So anyways, we have this interesting equation, 1 to the power z equals 1/2 plus root 3 over 2I. And we're going to be solving for z values. First of all, are there any solutions? We're going to check our results against Wolfram Alpha, and then, like I said earlier, we can talk about it, but maybe not in this video, maybe in the comment section down below. So if you have any ideas, go ahead and let us know. If you're new to complex numbers, go ahead and check out my lecture videos, and if you like algebra number theory, or you want to learn more about it, you can go ahead and check out my other channel, Cyber Math, Cyber with an S. Some people complain about me talking about my other channels, but I don't talk about them for 4 minutes. Like half the video is all promotions. No. I'm only talking about 30 seconds. I hope you don't complain about it. Anyways, so we have this equation, and how do we solve for z? I know we've done a similar problem before, like something like 1 to the power z equals e. I was under the impression that this would have solutions, and some people made a video about it, and you know how they titled it? Harvard entrance exam. 99 point blah blah whatever can solve this problem. Obviously, Harvard is not going to ask something like this, right? It never happened. But unfortunately, because of YouTube's algorithm, some people need to make clickbait videos. This is not a clickbait video. We're going to talk about it, and again, if you can correct me if I'm wrong, but there's different ideas. Anyways, so this definitely is essentially a wrong equality, because if you look at the absolute values, you have a number which is 1 on the left hand side. When you take the absolute values, you're going to get 1 from here, but the absolute value of e is obviously greater than 1. So this is not compatible, and I totally understand, because if you're on the unit circle, you can't really go out and find something that is e, right? Something like that. Anyways, but this should be, from that perspective, this should be okay. Why? Because if you look at the right hand side, you have a complex number whose modulus is 1. What am I talking about? If you look at the absolute value, its absolute value is 1, absolute value is 1. So I don't see a problem with that. Do you? Let us know if you do. So let's go ahead and just solve this problem and see what happens. So to be able to solve this, I'm going to turn these into polar forms. Now the left-hand side 1 can be written as a complex number as e to the power 2 pi ni, because on the unit circle, as you know, if you make 2 pi and multiples of 2 pi rotations, you're going to get to 1. Okay, it's a real number. So we're going to raise this to the power z, and then on the right-hand side, we have 1/2 plus root 3 over 2i. If you think about it real quick, 1/2 and root 3 over 2, it's going to give you something in the first quadrant, and that'll make a 60-degree angle, but we express it as pi over 3 in radians. This is real, this is imaginary. This is the modulus z, and the distance is the modulus for the absolute value. Make sense? Of course, in this case, modulus is 1, so I don't need to worry about it. But I can write this as e to the power I times pi over 3. Of course, you're allowed to add multiples of 2 pi. So if you want, we can go ahead and add 2 pi k to this, and then kind of write it like this. Because in the end, e to the power 2 pi ki is 1, so multiplying by 1 is okay. This should be fine, right? Any problem with that? I don't think so. So, obviously, some people can argue that, well, you don't really need e to the power 2 pi ni on the left-hand side. You can just write 1. But if I write 1, then I'm going to get 1 to the z, and what is that equal to? Is that equal to 1? Then if it's equal to 1, how is that going to be e to the power something, right? That's a good question. But anyways, let's proceed with this and see what happens. Now, this is going to give us e to the power 2 pi niz. Let's just clear the bases. So from here, we get 2 pi niz after multiplying the exponents. And here we get I times pi over 3 plus 2 pi k. Since we have e to the power on both sides, we can totally eliminate that. Now, we can simplify this, can't we? First of all, notice that we can pull out a pi, and that'll give us 2k plus 1/3. And here we get 2 pi niz. Oops, I wrote pi. Okay, too obsessed with pi. 2 pi. Okay, here's the pen. Come back. 2 pi niz. So I'm going to go ahead and cancel out the I pi from both sides. And then that's going to give me 2nz. So if I'm trying to solve for z, then I should divide both sides by n, right? Let's do that. Z equals 2k plus 1/3 divided by 2n. Oh, I forgot to say n and k are integers. Let me add that real quick. All right. So those are integers and they can be positive or negative. In this case, we have a fraction. We don't like that. Let's go ahead and multiply top and bottom by 3 so that we can get z in the simplest form. 6k plus 3 divided by 6n. Now, what is that supposed to mean? If k and n are integers, let's go ahead and explore some values, such as, for example, if k is equal to 1 and n is equal to 1, let's find out what happens. Z equals 9 divided by 6. Oops. We get 9 over 6, which can be simplified as 3/2, right? Okay. Now, is it true that 1 to the power 3/2 is 1/2 plus root 3 over 2i? That's a good question, right? So I can think of 1 to the power 3/2 in two different ways. One way is I can think of it as 1 cubed to the power 1/2, which means first I cube 1 and then I find the square roots. But of course, if you mean the principal square root or you're talking about both square roots. I think we're talking about all of them because I did not use the square root symbol. I didn't say, okay, we're going to do this, guys, and this should have a unique value because of real numbers, right? But this one means the square roots of 1 to the 3rd power, which is 1. So that should give us 1 to the power 1/2. What is 1 to the power 1/2? Well, 1 has two square roots. One of them is 1, the other one is -1. Because when you square both of these numbers, you get 1. Okay, so this didn't work out. So there's something problematic about it. Maybe I should try something else. How about k equals 0 and n equals 1? K equals 0, n equals 1. That should give me z equals 3 over 6, which is 1/2 again. I don't think that's going to work. So my goal is to get something nice. Let me think about it. I want to get something nice. Maybe I can use n equals 3, and that should work. You know why? Okay, I'll tell you. If I use n equals 3 and k equals 0, of course, then I should be getting z equals 3 over 9, right? Is that correct? 3 over 18, sorry about that. 3 over 18, and that should be 1 over 6. So the thing is, 1 to the power 1 over 6, because that's 1 to the power z, right? Because I'm directly doing it. Oops, I wrote 16. 1 to the power 1 over 6 is basically, we're talking about 6th roots of 1. Obviously, the principal 6th root is 1, but there's other ones. Like, okay, I can write this as e to the power 2 pi ni. To take the 6th root, I can divide by 6, so that should give me e to the power pi ni divided by 3. So for example, if n is equal to 0, that's 0. If n is equal to 1, I get e to the power I pi over 3. And that will be cosine pi over 3 plus I sine pi over 3. What's cosine pi over 3? Cosine 60 is 1/2. And this is root 3 over 2. Uh-oh, looks like we got a solution. But is this a general solution? I doubt it. But what will be the correct way to write it? Maybe we should not use a k and directly write this as 3 over 6n, but then that would be 1 over 2n. And again, that would not work all the time. So what are your thoughts? Let's go ahead and check the results from Wolfram Alpha. I'm also going to show you something else. Ready? Ta-da! Wolfram Alpha thinks this is false. Well, this is not a statement. It is a solution. But anyways, or it's an equation. How can an equation be false, right? Let's go ahead and check out the 6 roots of 1. And as I said earlier, this one is one of the 6 roots. So that should be a solution, don't you think? And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know, don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.